All right, thanks for having me, and let's actually get started. But before I move to the first couple of slides, who uses R here? Okay, some, not many. Good, so I'll basically go back to R first and then move on to text analytics. Now, of course, text analytics is this broad idea that you can use some kind of computational method or quantitative method to look at text. And it doesn't have to be using R. You can use, there are many languages that can be used to analyze text, but most of the time when people talk about text analytics, they're doing it using either Python or R. So Python is probably more traditional in that regard in terms of natural language processing, that sort of thing. But you can do pretty much everything with R as well. And of course, R is specifically designed for statistical analysis. So if you're doing stats, it already comes like out of the box, it's ready for that. Now, of course, you can also do the statistical analysis using Python by loading some modules and libraries, but R is usually kind of the go-to language for data analysis. So I will talk a little about R itself and then kind of use the tidy data format to discuss how R can be used for data analysis using text. So there are different terms that people use, and they are usually very vague. When people say computational linguistics or language analysis using statistics, it could mean a lot of things, right? So it could be that you're talking about natural language processing to look at sentence level meaning or word tagging. This is a very common interpretation of the word computational. But you could also be using regular expressions to build lexical or word lists, or analyzing whatever text you have, like social media, for example. You could just use regular expressions to, in a way, regular expressions would be like a very fancy control F, right? You can just find patterns, do replacements, and compile lists based on that. You can also use semantics for sentiment analysis, and you could just focus on that, calculate the similarity between texts. Especially important if you're trying to map like plagiarism, for example. So you can compare several texts and have some sort of similarity score that could raise some flags. So many applications there. So here I will do a little bit of, we'll do mostly B and C here. But at the end, there's a little bit of similarity calculation as well. Now, the idea that there's this thing called tidy data. Of course, we all know what tidy means, but tidy data is actually a term for a format of a data set. Now, if you have used Survey Gizmo, SurveyMonkey, Qualtrics, Google Forms, any of that, you'll realize that the output of the responses follows this wide format, right? So you have, like, if you have 100 questions, you will have 100 columns, which is really annoying when you have to analyze the data, because if those 100 questions are actually part of the same variable, now you have a problem because you have a variable that's spread all over the place, and you have to make it long as opposed to wide. So there's this kind of wide to long transformation that we almost always have to do before analyzing the actual data set. And that's really what tidy data means here. It just means that you have one variable per column, so you don't have a variable being spread, and one observation per row. That basically means that you have a super long data set as opposed to a wide one. Now, once we do that, and we don't have to do that for text, we could use matrices, for example. But if we do that with text, then everything that we already know from typical data analysis can be applied to text data analysis. So it's a very transferable kind of situation. It's very advantageous there. So the steps that will follow here are the typical steps in any kind of data analysis being performed on books or novels or whatever text you have. So first you have to load and tokenize a particular text. So it's almost like you're classifying everything so that it's ready for analysis. The second thing we'll do, just to see how that works, is to check the most common words. We can also do a word cloud with that. Word clouds are usually fun to look at, but they're not the most useful thing, right? It's just fun, but knowing the most common words, you can do a lot of things. Right? So sentiment analysis, for example, if you're worried about what people were saying about your brand or product, you will definitely want to know what the most common words are, and then you will classify them into positive or negative, or use some score for that. And that brings us to sentiment analysis, which is really kind of bringing number 2 there to the semantic analysis there. So this is what R looks like if you haven't used R yet. If you don't use R, you probably use something like SPSS or maybe SAS. There's Stata. I mean, there are many packages out there. And even though the other options, like even SPSS, even though they allow you to write code, technically, right, they're not really meant for that. Like SPSS was designed for you to click on things because it's easier, right? It's just more user-friendly. It's like Excel, only with more statistical power. Now, R, on the other hand, is the opposite of that. It's not supposed to be, user-friendly in that same way. So you're not really clicking anywhere. You're basically just writing text, right? So it's really a language first and foremost. And so this is what a script looks like. So you can see that at the top there, we have a lot of lines with the word library. Now, this is very common in most languages. You will have to kind of load different packages and libraries, and that's what we're doing there. So every library command there is loading a package. So for example, word cloud is a package. Do we need that package to create word clouds? No. We could actually do a word cloud from scratch ourselves. But the reason why we want to load the package is it's almost like it brings over all the functions that will facilitate the process, so we don't have to work that hard, right? So basically anything you want to do, there's probably a package out there that will help you do that. And right now, I think there are over 15,000 packages. So there's probably a package that will really do what you're looking for, so you don't have to do it from scratch. Now, it doesn't mean that there's no learning involved, because every package contains functions that you have to learn, and the functions have a particular syntax, different arguments that have to go in them. So there's some learning here, and so the learning curve for R is very different from the learning curve that you have for SPSS, right? Especially if you haven't coded before, it takes a little while to get used to it. But it can be intuitive. And one of the reasons why we're using these symbols here, this is called the pipe in R, is actually to make things a little more intuitive. So the problem with computers, many problems, right? But one of the problems is that when you have 5 functions, the first function that will apply is the one that's closest to the main argument, right? So if you have something like, what is the create a bunch of numbers and calculate the mean, the first function from left to right will be mean, and then the function for creating the numbers will occur, right? So if we do that here, for example, can you read that? Okay, so if we wanted to calculate the mean of a bunch of numbers, let's say the mean of 1,000 numbers that have mean 5, obviously that will be 5, right, because we're telling it. But you can see that what the computer is doing goes from right to left, right? So first you create the numbers and then you calculate the mean. Now that's easy for 2 functions, but if you have like 7 functions in a row, it's just very hard to follow what's happening because you have to start from the right. And we don't think like that, so roughly 5. So one of the main advantages of using that first package at the top called tidyverse is that instead of using a bunch of functions one after the other, we use them separately. And we connect them using this symbol called pipe. And that symbol can be read just like and then. So do this and then do that, etc., etc. And the advantage is that you flip the order. Now we're using the same order that we would actually do, right? So that we will use that throughout, so we'll have plenty of time to go over that. So tidyverse is the main package here, because tidy text, which may look like, oh, that's the one we're focusing on, that's just derived from tidyverse. It's using tidyverse to explore text. And then we also have a bunch of other packages here. Reshape2 is used to basically, as the name implies, reshape a table of data, right? ggthemes is just to make figures look prettier. Then we have GenAustin R. That contains all the data that we'll use. So you don't actually have to go online and search for the text to analyze it. it's actually inside that particular package already. That's not, of course, that's not always the case. Most of the time you want to go online and pull data from different sources, and you can do that directly from R, but in this case we actually have the data inside that package. And finally we have the word cloud package there. So this is how we can interpret what's going on between lines 8 and 11 here. So the first thing we're doing here, and I'll actually do it outside of the slides later because this is too static, right? So we can't actually see it working. So we are creating a variable, and we are just saying, look, this variable will contain all the books that are inside that package. Now you may be wondering, how does R know what this is? Right? That's just a command that contains all the books written by R. Well, the moment you load library Jane Austen R, it's going to load a lot of functions. So now it understands certain commands, right? One of the commands it will understand is this one called Austen_books. So when you type that, if you run that line, just Austen books and then brackets, it will print all the books. Well, the beginning, because otherwise it's useless. Like it's printing a lot of things. So what we're doing here is actually very easy to understand if you think of how the English language works as opposed to functions, right? So create a variable and assign to that variable the following. Take all the books in Austen there, the package. Then group the data by book, because we have multiple books. So it's a very intuitive function, really, because that's literally what we're doing. Then mutate, meaning change that set or that data by creating two new columns. The first column will be line number, and this will basically be the row number of the data. So this is a command. This is a name that it could be anything, you decide, right? But this is actually a command. It picks the row number of a particular data point. And the second column that we're creating is called chapter. This is because we want to have a column that says this is chapter 1, this is chapter 2, etc. It's not there yet, and I'll show you what I mean. This will be the cumulative summation or sum of a specific set of characteristics here. And to understand why that's there, let me just show you what it looks like. So I'll just move on to R here. This is R Studio. This is exactly the set of packages that we were loading before. So if we load all the packages, you can see that if I run this particular line, this is what it looks like. So there are 73,422 rows. This is what the top 10 look like. So you can see there is one column that contains the actual content of the book, and the second column has the title of the book, right? So this is going to be Sense and Sensibility until the end of the book. So it's just repeating that particular row. So this is the original data, but we need more here. We need to know where chapter 1 begins, what the line number is, etc. Now the nice thing about this, and this is probably coming from Project Gutenberg, every time there is a new chapter, it actually says chapter X. So it's not that hard to figure out how to find the chapters because it's telling us. It's not like we have to, find another way. So basically we're saying every time you see something like chapter and then a number, that is the information that I want you to extract. And we do that like this. So the line number is not a mystery because it's just, pick the line number. But here we're going to, and here you can see the example I mentioned before. This is the typical way you write a function. It's much harder to understand, right? Here it was much simpler. Take the books, then group by book, then blah, blah, blah. Here we're not doing that. So to really interpret this, you have to actually go all the way to the end and go left. So it's confusing in that way, right? So what we're doing is take the text and detect the following string. If you see chapter, and it has to be the beginning of the word and the string, if you see chapter followed by a number, this is just regular expression for a number. Could be any of these numbers here, and it could be capitalized or not, right? So we are ignoring the case. So if it says chapter lowercase or chapter uppercase, it doesn't matter, right? If we change this to false, then it's going to look for a chapter exactly like that, and it will not find that first chapter that we just saw because that's all capitalized. So doing that, you create two columns, and it's going to sum cumulatively the chapters. So when it finds chapter 1, when it finds the second chapter, it's going to assign number 2 to it, right? So automatically. Then we ungroup everything, and then we unnest tokens. This is a command that does all we want to do there. Let me show you what that looks like. So I'm going to run this entire thing here, right? And we will take our new variable and print the first 10 lines. So this is what it looks like. Now we have line number and we have chapter. Now it's going to be 0 because it's not the beginning of the chapter yet, right? So the moment the chapter begins, it will say, okay, this is where chapter 1 begins. So this is actually useful for us. We probably don't want to have number 1 here because it's not the chapter yet. So now it looks like this, and you can see we have a lot of rows now. So we have 7.25 plus 50 times 10 to the 5. It's just immense now. But that's fine. We don't care about that. And you can also ask the question, what are the books, right? So what are the levels of the book factor? So if you're familiar with R, this will be, oh yeah, I know how to do that. If you're not familiar, this is basically saying, look at tidy books, which is our new data. Inside that data set, there is a column called book. That's why there's a $sign. It's just saying inside that data set, there's a column called book, and that particular column, which is here, is a factor. And every factor has levels, right? So I want to know what are the levels of that factor. So when you run this line here, it will tell you there's 6 books. You can tell from the numbers here. So this is number 5. So there are 6. And we can only see the first one, of course, because there's so many data points there. So now this is a little better because we have tokenized the text. We have individual words now that we can work with. So this is now much easier to determine, what are the most frequent words, which words are the longest or shortest, etc. So this is much better now for us to analyze the text. But the problem is we have words here that we don't really care about, right? Words like the or by, and these are function words that we don't really want to analyze because they are not helping us determine if the text is positive or negative or whatever, right? How rich the lexicon is there. And so for that, we will do something called, we'll just want to remove the stop words. And we can do that in different ways, right? So if you are familiar with R, you know that, well, there are different ways you can basically look at a text and remove all the words that are function words, etc. But the first question is, how do you know what the function words are for a particular language, right? Presumably there's a lot of those, a lot of function words. Now the nice thing about this is you actually have an object here that's called stop words. This was installed the moment you loaded the package. And if you run it, you'll see that there is a list with more than 1,000 words that would be considered non-content word, right? So the list is already there. You don't actually have to compile anything. At least for English and some other languages, the list is already available. But if you're studying a language that has no list yet, you could do it yourself or just grab it from some other data frame and compile it. So now that we have that, we can just remove all the words that happen to be stop words, as they're called, right? And we do that by saying, take tidy books, create a new variable, which will be the old tidy books, take that, and then remove everything that matches what you have in stop words. It's like you're anti-joining the sets. And when you do that, now you can see that we no longer have the here. It's not there anymore. So for now, what I've done so far is we loaded the data which looked like this originally. Then we added a couple of columns using regular expressions to pick the number of the chapter and the line number. And the third thing that we did was to remove stop words. So now we have a text that's tokenized and contains only lexical content words that we can analyze, right? And this is usually the same set of steps that you would have for any text analysis, because you always want to get rid of stop words anyway. So that's pretty universal. Now, with the data that we have right now, that again looks like this, with that we can ask very simple questions. For example, what happened if I wanted to plot the most common words from most to least common, or at least the top X common words or something like that? You probably don't want to plot all the words in order of frequency because it wouldn't fit, right? And so this is the code for creating a figure. Now you'll see here that sometimes we have the pipe at the end of the line and sometimes we have a plus sign, right? So at the top we have pipes and then we start having plus signs all of a sudden. And that's basically because we are going from one package to another package in the middle of the command. And they're actually working on making things more consistent, but it looks inconsistent, but it actually makes sense when you look at the documentation. So what we're doing here is a sequence of steps. You can see at the top there that we don't have an equal sign, right? So before, like here, we had an equal sign at the top, and that was because we wanted to do something and assign it to a variable. So it will hold the result for us to access again, right? Here, we are not assigning it to a variable. We want to do a couple of things and then create a figure, and that's it. We don't want to save it in a variable or anything. I mean, you may want to, but here we're not doing that. You may want to save the figure, of course, right? But that's a different thing. So here's what we're doing. First, take tidy books. Then, so you can always read the pipe as then, count the words. That's it, right? Count the words. There is a column called word, of course. There must be some column there called word. That's why we're using word there. And when you do that, sort the count. So that sort equals true. Then the next step is to filter, only looking at words that appear at least 601 times. Because otherwise it will be too many words to plot, right? And you can change that number, of course. After that, mutate the data set by creating a new column, and that column will be called word. And word will be the original column called word, but now it will be reordered based on the number of times that it appears. So it will basically reshuffle the deck so that the top word, the most frequent word, will be at the top, right? And that's the end of the data preparation. So now the data is ready. The problem of doing all these steps at the same time is that if you're not used to seeing that, it's a very abstract set of steps, right? Because right now I'm telling you that here the data is ready, but you can't see the data because you're still, right? So we can actually break that down here. If I run just this part, which is the data preparation part, you can see what it looks like. So at that point, this is what R is processing. You can't see that because you haven't run the line yet, right? But you can see that the most common word is miss, and it goes down, and here's hope. So there are 13 words basically that we will plot. So this is the data after that step. You could, of course, break it down and say something like, let me create a new object, and then I'm going to use that object to plot it. So you can break it down into separate steps. But of course here we're just doing everything at the same time. So that's the data preparation. It's actually a very simple table, right? It's just a column with the word, a column with the number of times it appears, and arranging them in order from most to least frequent in that set. So how do we plot that? So the plotting begins with the ggplot command. There are dozens of ways you can plot things in R, but ggplot is by far the most developed package for that. So it's already in version 3 point something. So you can really do any kind of thing that you want, visually speaking, with ggplot as long as it's static. So if you want to do a plot that is interactive or moves around, that's not ggplot. That's another package. But there are easy ways to go from one to the other. So this is saying, take this function ggplot, which comes from that tidyverse package, and it's going to assume the data is coming from there already, because it's in a kind of a pipeline, right? So it understands. You don't have to say, take the data from the previous step because it's in a row. So X will be the word. It's missing there, but it's assuming that if you don't say anything and it's the first thing that comes up, that's X. The second would be Y. So this is X, this is Y. On top of that, so this is just telling R what the content of the plot will be, data-wise, right? But we don't know if it's a scatter plot, a bar plot yet. It's just the first layer. The second layer, and there's the plus sign, is to create a bar plot. And for that, we use geombar. And we're just saying stat identity. This just means don't calculate anything. Just look at the column that has the number and use that to plot. So just use the identity of the data to plot. Don't be smart, because geombar always tries to figure things out for you. So you're just saying, no, don't do that, right? The fill of the bar will be color dark green. If you just Google colors in R, there's going to be a huge list of options. So you can, because you may be wondering, how do I know that that's the name of the color? We can just Google it. There's a huge list, and you can just pick. There are many colors. You can even create your own color with RGB and other methods. Alpha equals 0.3 means transparency, right? So you may not want to have like dark green, solid color. So it goes from 0 to 1. 0 would be totally transparent. So 0.3 is like very weak dark green, right? And color means the border of the bar, not the actual fill of the bar. So just the color of the border. This is for the labels. We don't want to have a label for the x-axis because it will be obvious that it's the word, because the words will be there. Theme classic is just saying, I want this to look very minimalistic, not too colorful. And this is just telling R to angle the x-axis labels at a 45-degree angle, mostly because the words can be a little long and they can kind of run into each other, right? So this is what it looks like. So it goes from the least to the most. You could flip it. It goes from least to most frequent word based on n, right? And so we have the word. It's angled. It's also not touching the axis there. And pretty much everything we need is there. Now you could, let me show you the actual, this is the code. Now if we're using RStudio, which is basically a software that allows us to use R in a more fancy way. It's way better than the typical R the editor that comes with R. So here you can see we have 4 panes, right? So we have this pane, we have that, which is the script. This is where things will appear when you run them. This is where the figures will appear, right? And that's our environment. So all the variables that you create will appear there. So there's the tidy books at the top. One thing we could do here is, let's say you want to transform the y-axis into a logarithmic scale or something like that. Now that's actually very easy to do because you can just come here and instead of, actually let me be very explicit here. So I'm just going to say x equals word and y equals n. If you just type log of n, that's going to create a log plot. So it's the same, it's just typing 3 letters. You now have the log of n. Now you may want to change this name, right, by going to labs here. So we could just go here and type y equals n log scale or something like that, whatever you want. And now you change the label of the figure here. If you wanted to do that. We don't have to do that here, of course, given the scale that we find in the data. So you can just go back and remove that. And now, of course, we want to change the label back to what it was before. What happens if you want to save the figure? Right? I mean, there are different ways to do it. The best way to do it is to not use your mouse, right? It's always, the best way is not to click there, because you may be wondering, oh, there's something called export there. I could just go there. The problem of going there is it creates some problems with resolution and format that you may want. So an easier way to create a PDF version of that would be to use this command before the figure, then you run the figure, and then you run this other command, which means, okay, now close the process of saving the figure, right? So this is going to create a figure called frick.pdf, and the width and height are specified there. So you can kind of work out the balance, like do you want it to be super wide and not very tall? You can kind of work it out. You run that, then you run the figure, and then you run dev off. That's going to appear, RStudio GD equals 2, and you can see the figure is oops, wrong. Let me find that here. So here's the figure. And the nice thing about saving it like that, like this is PDF format, it's actually very light. You can see it's 5 KB. It's very, very light. But if you open it, and this has always been a problem in other, let's use preview. So let me show you the resolution here. So there's really, it's really crisp, right? You don't really have any problems with, you know, this is pixelated or that's not a problem. And it's not heavy, right? So it's super high resolution and very light. So it's perfect. So this is a simple example of how to plot something using ggplot in this particular case, ordering things. And this is how we could create a word cloud based on those data, right? So you take tidybooks, then count the words, and then use that command. Now here's the thing, you may be, if you're not used to R, you may be thinking, wow, okay, how am I going to remember all those commands, right? But the thing is you don't have to remember them, because the moment you have them typed, you can just always go back to them, copy and paste and adjust. And that's how a lot of people learn to use R. And these commands are not only here, you could Google them, there are books with the commands, and so by just copying and pasting and adjusting, you can definitely do the same thing. The other thing is, after you create your one plot with all the settings that you want to have, that's it, right? It's done. Now you can always use the same code. So it's not like, of course, after some years doing it, you will remember, but you don't have to. That's the point, right? So the third line there is basically saying, it's using that with command, which is basically a way to kind of separate tasks there. It's saying, with a particular thing, do something and give me the output, right? So word cloud is the name of the function. So take the column word and the column n. I want to have a maximum number of words of 100, and the colors just dark green, so everything will be dark green. And that's what you end up with. Now notice we're not using ggplot here. So this is yet another way of plotting things in R that, just an alternative. You could use ggplot, but it would require many more lines. So this is just quicker. And this is how you can see. Let me actually hide these lines here. So if you put a hashtag in front of something, R is not going to read that. And the reason you want to do that is because you may run that line accidentally, and so it's going to save it and save it and save it however many times you do it. So you can just comment it out, and if you want to resave it, then you just remove the hashtag. You can do that with Command-Shift-C or Control-Shift-C. Or you can just write hashtag, right? But it's, let's say you wanted to hide this entire thing. It's very quick if you just do Command-Shift-C. So this is the the word cloud. Now you can see it looks different, right? And that's basically because every time it runs it, it's going to shuffle things a little. So there's a random factor there. Okay, so word clouds are nice to look at, and I mean, they can be helpful for you to kind of visualize certain patterns. They're not that useful though, right? So let's do some sentiment analysis and bring that together with word clouds, because that can be more informative. So we will use some existing sentiment lists. So again, just like the stop words from before, we don't have to care. We don't have to worry too much about how do I know if a word is positive or negative. Well, other people have come up with that already, right? So you can use their data sets there. And here we're using, I mean, and there are different ones, right? So you can get ones from Bing. I think Google has a bunch, so there are different APIs for that. So here we're creating a new variable, and that variable will take tidybooks, again, the same variable from before. Then it's going to inner join, meaning it's going to add some information to it using the sentiments from Bing. Right? Then it's going to count using book as our reference, using the index of the line number divided by 200 here, and it's going to compute the sentiment, getting it from the sentiments or get sentiments function at the top there. Now, why am I using the 200 there? It's basically to break the book down into chunks, because you probably want to separate the book into different parts. It could be a chapter, but you could imagine that let's treat every 200 lines as a unit to kind of compute the sentiment as it goes, from the beginning to the end of the book. So you can change that number depending on what you're interested in. Here, we're just using 200. The next thing is to spread the table. So meaning instead of having a single column, you break it down into multiple columns. So you're doing the opposite from the Y to long. So it's long to Y transformation. Then we're going to create two columns. The first one will be positive sentiment minus negative sentiment. What does that mean? So again, this is very abstract because we're doing a lot of steps in a single, really in a single line of code, because we're just breaking the line. It could be just a single line that goes on forever, right? So let me show you the intermediate steps here so it's more intuitive. Let's say we stopped here. So before we are adding the column. So let's see what that looks like. So this is what it looks like after you inner join sentiments from Bing and you count the number of times that sentiment is found, right, by book, and it's separated into negative and positive. This is coming from Bing, right? So Bing contains the information. So this word is positive, this is negative, etc. So this is just saying that, in the first 200 lines in that particular book, we have 42 negative words and 85 positive words. That's what it's saying, right? So that's what that first half there is doing. The next thing, so the mutate part, is just saying, take that data set and create two columns. The first one will be called sentiment, and that will be subtracting, so positive minus negative, right? If we end up with a positive number, it means that that portion is mostly positive. If it's a negative number, it's mostly negative, right? So that's one way you could do it. There are many other ways you could do it, because here we are dichotomizing something that's continuous, right? So maybe you want to have something more scalar, something more fine-grained, but that's what we're doing for this one. So after you create the sentiment column, create another column that's called polarity, and if the sentiment is below 0, it means it's negative. And if it's above 0, it's positive. Otherwise, just write NA. If the number is actually 0, then just, we don't care. You could even write neutral or whatever word you want there, right? So now we're doing data preparation and plotting in 2 steps. So this is different from before, right? After that's done, this is the code to create the sentiment plot. And this is what it looks like. So you have the different books. This is beginning of the book, the end of the book, divided into bits of 200 lines. and everything that's blue is a positive sentiment, everything that's red is a negative one. And this gives you a sense of, okay, is this book getting worse towards the end? Is it more negative towards the end? Or is it getting better towards the end, or happier, right? This is especially good. Imagine that instead of books, you had periods of time, and you had, or maybe the x-axis is periods of time. These were different products or different strategies. And so you could see if the strategy is getting better reviews or worse reviews over time, right? So this is basically saying, okay, towards the end of this particular book, you have very negative words, right? And of course, you could create a word cloud, again, that includes the information about sentiment. So now I have positive and negative at the top there. So this is just making the word cloud a little more informative. And the last couple of things that you could do, for example, this is a very simple thing, but just to give you a sense of a very basic thing that you can do with text, is you can look at tidy books, then group by book, and then create a summary with the mean word length and the standard deviation of the word length. Now, these numbers shouldn't be that different, right? We know that, but just to give you an example. So this will be the mean of the number of characters per word, and this will be the standard deviation. So you can see here you have the book, the mean word length, and the standard deviation. You can see they're all very similar, which is not surprising, right? But if you had different types of text, they would be very different. If you compared something very informal with something very technical, then you would see a big difference there. And finally, you could do, this is a very simplistic example of lexical richness. You could calculate the number of unique words and divide that by the number of words to see how rich the vocabulary is, and order the books in descending order of lexical richness. So you would see here that, Northanger Abbey is richer than Emma, almost twice as rich in terms of number of words that are used only once, right? So this is, again, just a simple example using tidyverse, more specifically dplyr. So this is not even, this is text and analysis, but it's not like we were doing before using a specific package that's designed especially for that. All right, and this will be on the slide. So this is probably the best book to get started if you want to do text mining using R. And this is all I have. Thank you.